Some planets feel unimaginably distant the moment we hear their names, not because they are completely impossible to understand, but because they are so different from Earth that we barely know where to begin imagining them. Jupiter is one of those worlds. It is the largest planet in the solar system, but if we remember only its size, we still have not truly reached what makes it so extraordinary. Earth is the place where we are familiar with land, oceans, mountains, forests, clouds drifting across the sky, and cities glowing after nightfall. Jupiter is different. There is no solid ground to stand on, no shoreline, no valley, and no continent beneath your feet. What appears before us are thick layers of clouds, enormous currents of gas, and bands of color wrapping around a giant planet. Jupiter rotates very quickly. A day there lasts only about 10 hours. That rapid rotation stretches and twists its atmosphere, constantly reshaping it, like an enormous painting that never becomes still. Among those moving cloud bands is a reddish-orange region so distinctive that it has almost become Jupiter's signature. This is the Great Red Spot, a vast storm wider than Earth. It is not a colored mark resting on a surface, because Jupiter does not have the kind of solid surface we know on our planet. It is a real storm within the atmosphere, quietly turning through an immense span of time. When we look at the Great Red Spot, we are not only seeing the power of wind and gas, we are also seeing the endurance of emotion that has continued through many generations of human beings watching the sky. But if we stop with the cloud bands and the storm, Jupiter still has not fully revealed itself. Around this giant planet is an entire system of moons, quietly following their own paths. Among them, the four largest Io, Europa, Ganymede, and Callisto, are the most remarkable. Each has a very different face. Io glows in shades of yellow and orange, with volcanoes that remain continuously active. Europa is covered in cold ice, and beneath that frozen shell may lie a deep hidden ocean. Ganymede is so large that its diameter is greater than Mercury's. Callisto is more ancient, its surface covered with the scars of impacts preserved from a very distant past. These moons once changed the way human beings saw the universe. More than 400 years ago, there was an Italian astronomer named Galileo Galilei. He was among the first people to use a telescope to observe the sky in a systematic way. At that time, telescopes were still very simple, and their images were far less clear than those produced by modern instruments. But they were already powerful enough to open a new door. When Galileo pointed his telescope toward Jupiter, he saw several small points of light close to the planet. At first, they may have looked like ordinary stars, but over many nights, Galileo noticed that they did not remain still. Their positions changed around Jupiter. From that moment, he understood that those small points of light were not stars fixed against the background sky. They were moons orbiting Jupiter. This discovery was deeply important because it showed that not everything in the heavens revolved around Earth. Another planet also had objects moving around it. And from that moment, the sky in the human imagination became much wider. In this episode, we will not rush through numbers or names. We will move closer to Jupiter a little more slowly, beginning with its immense appearance, with the clouds rolling around the planet, with the Great Red Spot quietly turning in the atmosphere, and then allowing our attention to move one by one toward the four remarkable moons traveling beside it through the darkness. You only need to listen gently, as though we are taking one step at a time through a true story unfolding in space. And as the distance between us and Jupiter slowly begins to close, the first thing that appears is not land, an ocean, or a familiar horizon. Before us is only a giant world of gas, covered in bright and dark bands moving slowly across its atmosphere. From within those layers, the story of Jupiter begins to unfold, a story of clouds, winds, ancient storms, and strange moons quietly orbiting around it. As we move closer to Jupiter, the first thing that stands out is not a surface like Earth's. We do not see land, oceans, mountains, or the familiar patterns of light and darkness. What appears before us are vast bands of clouds wrapped around the planet in long layers. Those cloud bands come in many colors: white, cream, brown, and orange. They make Jupiter look like an enormous sphere covered in multiple layers of moving clouds. But these are not gentle clouds like the ones we know on Earth. They belong to a gigantic atmosphere, far deeper and more powerful than anything familiar to us. Jupiter rotates very quickly. A day on this planet lasts only about 10 hours. Because it spins so fast, its clouds are stretched into long bands around the planet. Some bands are brighter, while others are darker. Some regions may appear calm, but inside them, enormous currents of gas are still moving. We can understand it in a simple way. On Earth, wind may blow across a field, a city, or an ocean. On Jupiter, winds and gases move on a much greater scale. They do not travel across only one small region. They extend around the entire planet. Because of this, Jupiter does not look like a motionless sphere. It is more like a world that is always changing shape. Its cloud bands drift, swirl, stretch apart, and then blend into other regions of cloud. When we look at a photograph of Jupiter, everything may seem still, but in reality, the entire atmosphere is moving constantly. Among those cloud bands is one region that stands out more than all the others. It is the Great Red Spot, Jupiter's most famous storm. It is wider than Earth and has existed for a very long time. For now, we only need to remember that the Great Red Spot is not a colored mark on the planet's surface. It is a real storm within Jupiter's moving atmosphere. The most important thing to understand when looking at Jupiter is that we are seeing a planet without familiar solid ground. What we see is only the upper part of its cloud layers. Beneath them are deeper, heavier, and more complex layers of gas. Human beings cannot descend and stand on Jupiter the way they could stand on the Moon or Mars. So the cloud bands do more than make Jupiter beautiful. They are the way this planet reveals itself to us. They show us a world that is enormous, spinning very quickly, and always in motion through every layer of its atmosphere. Through those clouds, we begin to understand why Jupiter is so different from Earth. It does not tell its story through rock or oceans, but through clouds, winds, and gigantic storms. And among them, the Great Red Spot is the clearest sign of just how powerful Jupiter's atmosphere can be. Across the vast face of Jupiter, there is one reddish-orange region so striking that it cannot be mistaken for anything else. This is the Great Red Spot, the enormous storm that human beings have been observing for centuries. When people think of Jupiter, many first picture the bands of clouds wrapped around it. But the Great Red Spot is what gives the planet its most distinctive mark. It is wider than Earth, constantly rotating, and has lasted for an almost unimaginable length of time. From a distance, the Great Red Spot looks like a quiet whirlpool set among the cloud bands, but inside it, everything is in continuous motion. Gas swirls around the center of the storm, drawing in the surrounding cloud regions and forming a vast atmospheric system. Every current of wind, every smaller stream of gas helps sustain the life of the storm. It is not a passing event. The Great Red Spot is a reminder of endurance on a planet that is always in motion. What feels strange is that, despite being so powerful and enormous, this storm is completely silent. There is no howling wind, no falling rain, no thunder. All we see is that vivid reddish-orange color and the soft, steady motion of its swirling shape. It sounds almost contradictory. Jupiter's greatest storm is quieter than any storm on Earth, but that silence is part of what makes it so mysterious and so captivating. It invites the observer to pause and look more closely. The reddish-orange color of the Great Red Spot is not the color of soil or stone. It comes from particles and chemicals in the atmosphere that are exposed to sunlight, mixed together, and stirred within the storm. Scientists are still studying the exact reason why it has kept this distinctive color across so many decades. But whether seen with the eye through images or through photographs sent back by spacecraft, that reddish-orange hue is enough to make the Great Red Spot recognizable. helping Jupiter stand out among countless other worlds in the universe. Unlike storms on Earth, the Great Red Spot lasts an extraordinarily long time. On Earth, storms usually last a few days, or at most a few weeks, before fading away. On Jupiter, a storm can last for centuries. It was there before the age of telescopes, remained when modern spacecraft passed by, and is still turning today. Over such a long span of time, the storm is not completely unchanged, but its changes happen very slowly. Its size, shape, and color may shift over decades, even across generations of observers. The motions within the storm are also unusual. Gas circles around the center in a giant rotation, while around it, other atmospheric currents continue moving in different directions. The interaction between large and small streams of gas creates smaller swirls and regions of different pressure, allowing the Great Red Spot to be both stable and constantly changing at the same time. It is part of Jupiter's rhythm, a rhythm that human beings can only watch from the outside through telescopes and spacecraft. What is especially fascinating is that the Great Red Spot is both powerful and quiet. Powerful because it is larger than Earth, because it has lasted so long, and because it exists inside a vast atmosphere filled with energy. Quiet because all of that motion happens in a distant place, without sound, without the kinds of signs human beings usually associate with weather on Earth. When we look at the Great Red Spot, we can feel something of Jupiter's atmospheric rhythm, patient, enduring, and never at rest. The Great Red Spot is not only a storm, it is a sign of the planet's strength and endurance, showing that a giant gas world can hold on to phenomena far longer than anything human beings have ever experienced. It reminds us that time and rhythm on other worlds are completely different from the familiar pace of life on Earth. From that reddish-orange whirlpool, our attention begins to move farther outward. Around Jupiter are many moons, each traveling in its own rhythm. Among them, the four largest Io, Europa, Ganymede, and Callisto carry stories of their own, each with its own color, its own character, and its own distinct pace. They are small worlds quietly circling a giant planet, and with the Great Red Spot as such a recognizable landmark, they become even easier to imagine in the mind of the observer. As our attention moves a little farther away from Jupiter, a small but vivid point of light immediately draws the eye. This is Io, the brightest and most volcanic of the four large moons. From the first image, Io appears in a strange mixture of yellow, orange, and white, both violent and beautiful at the same time. It is not a quiet world. On the contrary, Io is constantly moving, changing, and filled with energy in its own unique way. Across Io's surface, volcanoes remain continuously active. Red-orange lava flows stretch outward from volcanic openings, winding across regions of hardened rock. White and gray plumes rise from the vents and mix with sunlight, creating shifting layers of color and shadow. Each stream of lava looks like a long thread of fire laid across the surface, forming a scene that is both powerful and alive with motion. When we look closely, Io does not resemble a cold stone orbiting a planet. It looks more like a world of fire, slowly circling Jupiter, maintaining a rhythm of its own. Io's restless nature does not come only from its surface. Jupiter's enormous gravity, together with the pull of the other moons, causes Io's interior to stretch and compress again and again. This process produces heat, causing magma to rise and volcanoes to erupt continuously. That is why Io is the most volcanically active world in the solar system, even though it is not close to the sun in the way Earth is. Its surface is constantly changing. New volcanic openings appear, lava flows spread farther, and new bright and dark regions form, keeping Io vivid and dynamic. From far away, Io is only a tiny point of light. But when we look more carefully, the colors, brightness, and movement across its surface make the moon seem almost alive. It is small compared with Jupiter, yet the force and energy within it are more intense than we might imagine. Beneath the immense presence of Jupiter, Io still keeps an identity of its own, following its own rhythm, while remaining subtly shaped by the giant planet it orbits. Io is more than a volcanic moon. It shows that even small worlds can have energy and character of their own. A planet as large as Jupiter may appear majestic, but the moons around it also carry independent stories, sometimes violent, sometimes gentle, but always unfolding in their own way. Io is one of the clearest examples of that diversity. Heat, light, and motion all blend together to create a world that is brilliant, active, and strange. By observing Io, human beings also begin to notice a delicate balance in the universe. Even though its surface is always hot and its volcanoes erupt repeatedly, Io continues to follow a steady orbit around Jupiter. That gravitational bond keeps the moon on a stable path, but it does not silence the activity inside it. Before us is a small world of fire, energetic and restless, yet gently held in place by Jupiter. Compared with Earth, Io is like an extreme version of volcanic activity. On Earth, a volcanic eruption may affect one local region. On Io, many volcanoes can remain active at the same time across the entire surface. It is a small world, but so powerful that even a distant view gives the impression of energy flowing through it at every moment. Yet Io is not only heat and fire. With every observation, its colors, brightness, and shapes change slightly. New lava flows appear. Regions of molten rock spread outward, creating a scene that is violent but also guided by a rhythm of its own. That rhythm gives the moon both power and a quiet kind of beauty, mysterious but not unreachable. What makes Io truly fascinating is its delicate contrast. Between its small size and Jupiter's enormity, between violent activity and steady motion, between glowing fire and shadow. Io is a vivid reminder that within the solar system, not everything large is active in the same way, and not everything small is quiet. After watching Io for long enough, a feeling of closeness slowly begins to grow. A small moon, powerful, dynamic, and intense, continues to circle Jupiter while telling a story of its own. And as our attention leaves Io, it naturally turns toward the remaining moons, where stillness, cold, and ice will open different stories softer, but no less strange or mysterious as our journey continues around this giant planet. After the intense yellow and orange colors of Io, Europa appears with an entirely different feeling. Before going any deeper, it helps to understand clearly what Europa is. Europa is not a planet. It is one of Jupiter's moons, meaning it is a smaller celestial body orbiting this giant planet. Just as our moon circles Earth, Europa follows its own path around Jupiter. But Europa is very different from the moon we know. It is a bright, cold world covered in ice. And the reason it has attracted so much attention is the possibility that liquid water may exist beneath that frozen surface. We have just passed Io, a moon filled with volcanoes, where the surface is constantly changing as hot material rises from within. Io feels like a world that cannot hide its energy. It erupts, changes color, and spreads fresh material across its surface, giving the impression that everything there is always active. Europa is the opposite. It does not impress us with fire. It has no intense yellow-orange color and no easily visible volcanic regions. When we look at Europa, the first thing we see is a bright, cold surface covered in ice. Its colors are softer and quieter, like a small frozen sphere moving silently around Jupiter. Europa is a little more than 3,100 kilometers across, slightly smaller than Earth's moon. Beside Jupiter, it looks very small because the giant planet is so enormous. But size is not what makes Europa most special. What draws attention to this moon is the layer of ice on its surface, and one very simple question: what lies beneath it? From far away, Europa can look like a bright and fairly smooth sphere. But when human beings obtained clearer images, that surface turned out to be anything but simple. Many long lines run across the ice. Some are thin, like cracks in glass. Others are darker, like old fractures that once opened and later closed again. In some places, These lines cross over one another, making the surface look like a vast sheet of ice that has been stretched, broken, and then frozen again over time. Those fractures are not only beautiful details on the surface, they show that Europa's icy shell has experienced stress. It has been pulled, compressed, or shifted. If Europa were simply a solid ball of ice frozen all the way through, its surface would be much easier to understand. But the long fractures and differently colored regions of ice lead scientists to think that beneath this cold shell, there may not be a completely motionless solid body. There may be liquid water. Before using scientific terms, let us imagine it in the simplest way. On Earth, the oceans are exposed to the open air. We can see the sea, the waves, the shore, and sunlight reflecting from the surface. But if water lies far below a thick layer of ice, hidden from view, with no sunlight shining down and no sky above it, then it becomes a sealed body of water. It may still be liquid, but it would be completely different from the seas we are used to seeing. A body of water beneath the surface is called a subsurface ocean. Subsurface simply means that it lies below the outer crust. So when scientists say Europa may have a subsurface ocean, they do not mean that blue seas exist openly on its surface as they do on Earth. Europa's surface is still ice. The idea is that beneath that cold shell, there may be a vast region of liquid water, completely hidden from view. This is why Europa has become one of the most closely studied places in the solar system. Liquid water is extremely important to life as human beings understand it. On Earth, almost every form of life depends on water. Life exists not only in warm, sunlit places, but also at the deep ocean floor, in cold regions, and in dark and harsh environments, as long as water, energy, and the necessary materials are available. Still, this needs to be stated clearly. Europa may contain liquid water, but that does not mean it definitely contains life. Water is an important condition, but it is not enough by itself to prove that living organisms exist there. What makes Europa worth studying is that it may hold a very unusual environment, a surface that is extremely cold, with water possibly remaining liquid underneath for a very long time. The next question is natural. Europa is so far from the sun, so why would all the water beneath its surface not freeze solid? If we think only about sunlight, Europa is indeed very cold. It is much farther from the sun than Earth, so the sunlight and warmth reaching it are weaker. This makes its frozen surface easy to understand. But Europa is not influenced only by the sunday. It is also pulled by Jupiter's gravity. Gravity is the force of attraction between objects with mass. Earth holds the moon in orbit through gravity. The sun holds the planets through gravity. Jupiter also holds Europa in orbit, causing the moon to continue circling around it. But Jupiter's pull does more than keep Europa on its path. It also stretches the moon slightly in a repeated way. As Europa travels around Jupiter, its interior may be gently compressed and expanded, not enough to break it apart, but enough to create a very small deformation that happens slowly and repeats over a very long time. Imagine a piece of rubber or another soft object being bent back and forth again and again. After some time, its interior may become slightly warm, not because it has been placed near a flame, but because repeated bending and squeezing create heat. On Europa, Jupiter's gravitational pull may create a similar kind of internal warming, but on the scale of an entire moon. The process in which an object is slightly deformed by gravity and produces heat inside is called tidal heating. Before hearing the word tidal, do not think only about ocean water. On Earth, the moon pulls on the oceans and creates tides, causing sea levels to rise and fall. On Europa, the word refers to gravitational forces that gently compress and stretch the entire moon. That repeated motion can generate heat inside it. This heat may help prevent some of the water beneath the ice from freezing completely. In simple terms, Europa is cold on the outside, but it may be warmer inside because Jupiter has been pulling and flexing it for an immense length of time. That makes Europa different from an ordinary frozen sphere. If it were simply ice all the way through, the story would be much simpler. But the fractures on the surface, the possibility of water below, and Jupiter's gravitational pull make this moon deeply interesting. Outside is ice. Inside may be water. The surface appears quiet, but the frozen shell shows signs that it has changed. An easier image is a frozen lake on Earth. When a lake freezes, we may see white cracks, long fractures, or regions of ice with different colors. These marks show that the ice has been under stress, that it has expanded, contracted, or shifted because of temperature and movement beneath it. Europa is not a lake, it is an entire moon. But the image of a frozen lake helps us understand one thing. A cold surface does not mean everything below it is completely still. If an ocean exists beneath the ice, it would be very different from Earth's seas. There would be no blue sky above it, no sunlight reaching the water, and no wind creating waves. It may lie in darkness, sealed beneath ice, under great pressure, in an environment completely unfamiliar to human beings. And yet, this is exactly what makes Europa so fascinating. On Earth, life is not found only in comfortable places. Human beings have discovered organisms at the deep ocean floor where sunlight never reaches, in cold regions, and in environments that were once thought too harsh for life. This does not prove that Europa has life, but it helps us understand that if a place contains liquid water, energy, and the necessary materials, then it is worth studying very carefully. Before using the phrase, an environment suitable for life, it is helpful to understand it simply. It does not mean that living organisms definitely exist there. It only means that the place may contain some of the conditions life usually needs: liquid water, a source of energy, and certain chemical materials. With Europa, the question is not, does life definitely exist there? A better question is, does this place have enough of the right conditions to deserve further study? Scientists want to know how thick the ice is, whether there truly is water beneath it, whether that water is salty, and whether the ocean, if it exists, touches the rock below. If water comes into contact with rock, chemical reactions may occur. That matters when we think about whether Europa could support an environment suitable for very simple forms of life. Europa is therefore not a place for rushed conclusions. It is a place for listening to signs. The first sign is an icy surface filled with fractures. The next is the possibility of water beneath it. Then comes the gravitational pull of Jupiter, which may create internal heat. Each sign by itself does not tell the entire story, but when they are placed together, Europa becomes a frozen moon with a story far deeper than its simple appearance suggests. This makes Europa very different from Io. Io is like a place that reveals everything on the outside. It is hot, powerful, colorful, and filled with volcanoes. Europa keeps its questions inside. It is not loud, it does not erupt violently, it does not overwhelm the observer with intense colors. It has only a bright icy surface and long fractures. But those fractures are exactly what make people wonder what lies beneath. This contrast makes the Jupiter system so rich. One moon shows us fire, another shows us ice. One reveals its energy across the surface. The other makes us think about what may be hidden beneath a frozen shell. Both orbit Jupiter and both are shaped by the giant planet, yet they tell completely different stories. Space missions designed to study Europa follow that same careful approach. They do not travel there to immediately declare that life exists. They go to observe the surface, measure the ice, search for signs of water below, and understand the moon's environment more clearly. Each new piece of data is like a small fragment that makes the larger picture a little clearer. For the listener, there is no need to remember the name of every spacecraft or every instrument. It is enough to hold on to this simple idea. Europa is an icy moon of Jupiter. Its surface is covered in ice and crossed by long fractures. Beneath that ice, liquid water may exist. And if water is there, the story of this small moon becomes much larger. There is a very particular feeling that remains when we turn away from Europa. It is not the overwhelming force of fire we feel when looking at Io, and not the sense of being dwarfed by Jupiter's immense size. Europa leaves behind a quieter kind of curiosity. It makes us think about things beneath the surface, things that do not reveal themselves immediately, questions that require time. Perhaps that is why Europa stays in the memory for so long. It does not need to be brilliant. It does not need to be violent. It does not need intense colors. It only needs a bright shell of ice, long fractures across the surface, and the possibility that a hidden ocean may lie beneath. That alone is enough to make Europa one of the most remarkable places in the solar system. As we leave Europa, our attention begins to turn toward another moon. After a frozen world defined by what may lie beneath its cold shell, we will meet a place that feels much larger: Ganymede. It is the largest moon orbiting Jupiter, and the largest moon in the entire solar system. If Europa draws our curiosity toward what may be hidden below the ice, Ganymede first captures our attention through its sheer scale, a moon so large that it is easy to forget it is still orbiting another planet. As we leave Europa behind, the mystery of its icy shell and the ocean that may lie far beneath it still lingers. But as our attention moves farther through the Jupiter system, another world begins to appear. It does not impress us with blazing volcanoes like Io, nor does it hide its secrets beneath a bright shell of ice like Europa. Ganymede enters the story through something entirely different. It is Jupiter's largest moon, and also the largest natural satellite in the entire solar system. Its diameter is about 5,268 kilometers, making it larger than Mercury and much larger than Europa. That fact alone makes this world remarkable. It is still a moon, still orbiting Jupiter, still held in place by the gravity of the giant planet. But it is large enough that we cannot think of it as only a small object, quietly traveling alongside something greater. Ganymede feels like a world of its own, broad, quiet, and clearly present in the darkness around Jupiter. If Io makes us think of fire, and Europa makes us think of ice and hidden secrets, Ganymede brings the feeling of a vast world shaped by an immense span of time. Its surface is a mixture of ice and rock, with ancient dark regions and brighter areas crossed by long grooves. The darker regions appear to be older parts of the surface, where impact scars have remained for a very long time. The brighter regions contain more fractures, long grooves, and complex breaks, as though the moon's crust was once stretched, cracked, shifted, and then frozen into a new shape. Looking across this world of ice and rock, we do not see the open violence of Io. There are no red-orange rivers of lava flowing across the surface. There are no towering plumes of material rising from volcanoes. Instead, we find the stillness of a large world with many layers of history resting on top of one another. One region may have remained in place for a very long time. Another may have changed under forces from within. The long grooves resemble wrinkles across a surface that was once under pressure, partially renewed, and then left to remain for billions of years. What makes Ganymede remarkable is not limited to its surface. Beneath those layers of ice and rock, scientists believe that deep layers of liquid water may exist. We should not imagine an open ocean beneath a sky, like the oceans of Earth. If water exists there, it would be hidden beneath extremely thick layers of ice, lying in darkness, under enormous pressure, and completely separated from sunlight. There would be no waves breaking against a shore, no wind passing over the surface, and no blue horizon. It would simply be a body of water existing very far below, locked beneath the frozen crust of a distant moon. That possibility makes Ganymede an important part of the story of Jupiter's moons. Europa already made us think about an ocean hidden beneath ice. With this larger moon, that idea does not disappear. It becomes broader. In the Jupiter system, water may not belong to only one moon. It may exist in different forms, at different depths, and in environments very different from the seas of Earth. This is what makes icy moons so interesting to study. They show that even very far from the sun, beneath cold outer shells, there may still be regions of matter that have not frozen completely solid. The reason water may remain beneath the ice is connected to heat inside the moon. Ganymede does not receive as much warmth from the sun as Earth does, but it is not simply a dead ball of ice. In the past, Jupiter's gravity and interactions with other moons may have stretched and compressed its interior, producing heat. Some heat may also come from the moon's formation and the way its interior separated into layers. In simple terms, Ganymede is not only a cold shell on the outside. Inside, it may have a layered structure, where ice, water, rock, and heavier materials combine to form a complex world. Another rare feature that makes Ganymede stand out is its own magnetic field. This is very unusual for a moon. Earth has a magnetic field, and Jupiter has an extremely powerful one. But a natural satellite with a magnetic field of its own is far less common. A magnetic field cannot be seen directly with the naked eye. We cannot look at a photograph of the surface and see it as a glowing ring around the moon, but it leaves signs through the way it interacts with charged particles and with the environment around Jupiter. We can imagine a magnetic field as an invisible region of influence. It is not a solid wall and not a shell that can be touched, but it suggests that something deep inside this large moon is active in a very important way. To create its own magnetic field, Ganymede needs an electrically conductive region moving within it, possibly connected to a metallic core. This means it is not simply a sphere of ice and rock, it is a world with a true internal structure. Ice and rock near the outside, possible layers of water farther below, heavier materials deeper still, and perhaps a central core that helps produce the magnetic field. Ganymede takes about 7 Earth days to complete one orbit around Jupiter. Compared with Io and Europa, it lies farther from the giant planet, so tidal forces do not affect it as intensely as they affect Io. Because of this, its surface is not constantly renewed by volcanic activity, and it is not covered in dense fractures in quite the same way as Europa. It preserves more ancient terrain, while still carrying signs of changes that once took place in its crust. That mixture gives Ganymede a character of its own. It is not completely young, and it is not completely inactive. It has dark regions filled with impact craters, like memories of an immense span of time, but it also has brighter regions crossed by grooves and fractures, showing that the crust was once deformed. On a moon this large, the past is not held in a single mark. It spreads across many different regions, each one preserving part of its history. When Ganymede is placed beside Io and Europa, the differences become clear. Io is a world releasing its energy outward through volcanoes. Europa is a world hiding its questions beneath bright ice. Ganymede feels larger, quieter, and more layered. It does not need brilliant color to become remarkable. Its size, complex surface, possible hidden water, and magnetic field are enough to make it stand apart. It shows that a moon can be more than an object orbiting a planet. It can be a small system of its own, with an internal structure, a surface history, and an environment all its own. There is something beautiful in thinking about Ganymede this way. From very far away, it appears only as a small point of light close to Jupiter, much like the points Galileo saw through a simple telescope more than 400 years ago. But behind that point of light is a world larger than Mercury, with a surface made of ice and rock, ancient regions, long grooves left by movement in the past, possible deep layers of water, and even a magnetic field surrounding it. A tiny point in a telescope has become an entire world in human understanding. Ganymede broadens our journey through the Jupiter system. It reminds us that this system contains more than the violence of Io or the mystery of Europa. It also holds large and complex worlds, quiet in appearance but far from simple. Some places do not need to erupt, glow with intense color, or raise the question of life directly in order to make human beings pause. Their scale and depth are enough. As we turn away from the largest moon, what remains is a feeling of vastness, not the vastness of Jupiter, but the vastness of a moon that almost resembles a small planet. It orbits another world, yet contains many layers, many traces, and many questions that remain unanswered. From this immense moon, our attention begins to move farther outward toward Callisto, the outermost of the 4 Galilean moons. If Ganymede impresses us through its scale, internal structure, and possible deep layers of water, Callisto leads us toward a different feeling, the feeling of immense time. There, an ancient surface covered in impact craters resembles an old record of the solar system, preserving marks that many other worlds have already erased. In the next part of the journey, our attention moves toward the outermost moon, where the surface looks very old and deeply marked by time. Callisto. It is a large world with a diameter of about 4,820 kilometers, slightly smaller than Ganymede, but still larger than both Europa and Io, large enough to feel like a world of its own in the distant reaches of Jupiter's system. Its surface is covered in rock and ice, with dark and bright regions mixed together. Unlike volcanic Io or the fractured ice of Europa, Callisto is quiet. Its entire surface is filled with craters of many sizes, giving it the appearance of a map that has recorded one impact after another over billions of years. Some enormous craters stretch for hundreds of kilometers, overlapping with smaller ones and leaving the surface rough but clearly marked. At a distance of about 1.88 million kilometers from the center of Jupiter, Callisto takes around 16.7 days to complete one orbit. At that distance, Jupiter's gravitational pull is weaker, so the outer shell is less strongly deformed. Because of this, ancient impact scars have remained largely preserved, making Callisto feel like a natural museum of collisions from space. Looking more closely, we can see enormous circular structures formed by concentric rings, such as Valhalla, the mark left behind by an extremely powerful impact. These rings stretch across thousands of kilometers, revealing the force of the object that once struck Callisto. Even today, that immense pattern remains visible across the surface. Beneath the outer layer of ice and rock, liquid water may still exist, though in a very quiet form. If it is there, the water lies deep below, hidden beneath a thick shell of ice. It does not reveal itself as clearly as the possible water beneath Europa's surface, and it produces no obvious sign. Yet that possibility alone makes Callisto worth studying, because part of its story may still be hidden beneath its silent exterior. What makes this moon stand apart from the others is its age. It is not violent, not brightly colored, and it has no open ocean or erupting volcanoes. Everything changes slowly, and because so little has disturbed the surface, many ancient impact marks remain. When we look at Callisto, it feels as though we are looking at a world that has preserved most of its history, with the past still visible across its surface. When placed beside the 3 moons we have already seen, the differences become clear. Io is violent and active. Europa is cold and mysterious, with a fractured icy shell. Ganymede is large and complex, with many possible layers inside. Callisto stands out through its ancient surface, its many craters, and its deep stillness. This helps us imagine the Jupiter system as a collection of very different worlds. Each large moon carries its own story. Io is hot and active, Europa is icy and may contain water. Ganymede is vast, with a complex internal structure. Callisto is ancient and preserves the marks of impact. All 4 orbit Jupiter together, creating a diverse system in which each moon represents a different way of existing. Callisto brings our journey through the 4 great moons to a quiet close. It is not brilliant or violent, but every crater and every bright or dark region carries a story that reaches back billions of years. Through Callisto, we begin to understand that not every world needs to be dramatic in order to matter. Sometimes, silence and stability preserve the most valuable information of all. After traveling past Jupiter's 4 largest moons, we can pause for a moment and look at the entire system more clearly. Until now, each moon has appeared as a world of its own. Io stands out through its volcanoes and the yellow-orange colors of its heated material. Europa leaves behind a colder, brighter feeling, with its icy shell and the possibility of liquid water below. Ganymede is remarkable for its enormous size, large enough to be wider than Mercury. Callisto is entirely different, quieter and darker, with a surface covered in ancient depressions left behind by objects from space. When we look at each place separately, it is easy to remember it through one main feature. Io is fire, Europa is ice, Ganymede is size, Callisto is the mark of time. But when the four moons are placed beside one another, the story becomes much broader. They are no longer four tiny points of light around Jupiter. They become four different worlds, all orbiting a giant planet and all influenced by its gravitational pull, yet each developing in its own distinct way. This is what makes the Jupiter system so remarkable. A giant planet does not have only storms, clouds, and colored bands across its visible atmosphere. Around it are smaller worlds, each resembling a different expression of nature. One is so hot inside that its volcanoes remain continuously active. Another has a frozen surface, while water may still exist beneath it. One is so large that it almost resembles a small planet. Another changes very little and has therefore preserved countless impact marks from the distant past. When we hear the word moon, we may imagine a simple object, small, cold, and quiet. But the four Galilean moons show us the opposite. A moon can be extremely violent. A moon can hide water beneath ice. A moon can have a complex internal structure. A moon can preserve the history of impacts far longer than many other surfaces in the solar system. Moving outward from Jupiter, these differences also follow a pattern of their own. Io lies closest to Jupiter and experiences a stronger gravitational pull, causing its interior to be heated more intensely. Because of this, it has become one of the most volcanically active worlds human beings have ever discovered. Europa lies a little farther away. It does not erupt like Io, but its icy surface and long fractures make us think about an ocean hidden below. Ganymede travels farther out, larger and quieter, carrying both bright and dark regions across its surface, along with the possibility of deep water inside. Callisto is the outermost of the four. Because it experiences less intense stretching and compression, its surface has preserved many more ancient marks. Seen in this way, the four moons resemble four different answers to the same question. What kind of world can form around Jupiter? The first answer is Io. It can become a hot and violent place, constantly reshaped by volcanoes. The second answer is Europa. It can become a cold and bright world covered in ice, yet still make human beings wonder about liquid water below. The third answer is Ganymede. It can grow larger than a small planet and develop features that prevent us from seeing it as a simple satellite. The fourth answer is Callisto. It can remain quieter and older, preserving traces that many other worlds have erased. This helps us understand that Jupiter is not only a single planet, it is more like the center of a small system. Of course, Jupiter is not the Sun, and its moons are not planets. But when we look at how they orbit Jupiter, how they are shaped by its influence, and how each one has its own surface and history, the Jupiter system begins to feel like a smaller version of the diversity found throughout the solar system. At the center is the giant planet, covered in cloud bands and enormous storms. Around it move large moons, each with its own colors, surface, and story. Farther out are many smaller moons, dimmer, less familiar, and more difficult to observe, but still part of this vast system. Everything moves together, not chaotically, but along stable orbits that have continued for an immense length of time. That stability makes the scene especially remarkable. Io does not drift away. Europa continues to follow its steady rhythm. Ganymede keeps circling Jupiter along its wider orbit. Callisto remains farther out, like a quiet world at the outer edge of the four great moons. Each has its own speed and distance, but all of them belong to the same system. When Galileo saw them more than 400 years ago, he observed only a few small points of light near Jupiter. Yet those tiny points changed the way human beings understood the sky. They showed that not everything revolved around Earth. Some objects were moving around another planet. Jupiter had a system of its own. From that simple discovery, humanity began to see the universe in a much broader way. Today, through telescopes and spacecraft, those small points of light are no longer only points. They have names, images, surfaces, and stories of their own. We know that Io is not as quiet as it appears from far away. We know that Europa has fractures across its ice. We know that Ganymede is larger than Mercury. We know that Callisto preserves a great number of ancient impact craters. Each discovery makes our image of Jupiter deeper. It is no longer only a large sphere in space, but the center of many worlds traveling beside it. What is especially important is that these 4 moons do not need to resemble one another in order to form a system. In fact, their differences are what make them so memorable. If all 4 were identical spheres of ice, their story would be much simpler. Reality is far richer. One place is hot, another is cold. One is extremely large, another is extremely old. One changes quickly. Another preserves its marks for immense spans of time. All of them exist around the same planet. This way of seeing helps us avoid imagining the universe as an empty and repetitive space. Within the region surrounding Jupiter alone, there are enough different kinds of worlds to keep human beings observing for centuries. And the longer we observe, the more we realize that places appearing tiny and distant from Earth can contain an extraordinary amount of detail. One small point of light may be a volcanic moon. Another may be an icy moon. A third may be larger than Mercury. Another, farther away, may preserve impact scars from a very distant age. Once we understand this, the way we see the Jupiter system begins to change. It is no longer the image of one large planet with a few objects traveling around it. It is a collection of different worlds, all existing within Jupiter's vast region of influence. After passing the 4 great moons, what remains is not only surprise at each individual place. More important is the realization of how diverse the entire system is. Jupiter may be powerful because of its size, its storms, and its immense gravity, but its system becomes even more memorable because of the moons surrounding it. These moons make the giant planet feel like a place filled with many stories, rather than only a large object in space. In the next part of our journey, our attention can move beyond the 4 Galilean moons. Jupiter is surrounded by far more than these 4 great worlds. There are many smaller moons, dimmer, less famous, and more difficult to observe that still help form the vast system around the planet. They may not stand out like Io, Europa, Ganymede, or Callisto, but their presence reminds us that the region around Jupiter is far more crowded and complex than the unaided eye could ever see. After looking at the 4 largest moons, we might feel that the Jupiter system has almost fully revealed itself. But this giant planet is surrounded by far more than those 4 great worlds. Jupiter also has many smaller moons. According to NASA, as of March 2026, 101 moons of Jupiter had been officially recognized by the International Astronomical Union. That number may continue to change in the future because the smallest satellites are often extremely faint, difficult to track, and confirmed only after many observations. But simply knowing that a large population of smaller moons exists beyond the 4 familiar Galilean satellites is enough to show us that the Jupiter system is far wider and more complex than it first appears. These smaller moons do not resemble Io, Europa, Ganymede, or Callisto. Most of them do not have the clear, rounded shapes of the larger satellites. Many are only small, dark, irregular objects, resembling pieces of rock or ice that have been captured and held in orbit by Jupiter. If the 4 Galilean moons are like 4 great worlds with clearly recognizable identities, the smaller satellites are more like ancient fragments, silently circling the planet. They are mentioned less often, but they remain an important part of the Jupiter system. This helps us understand one simple point. A giant planet like Jupiter does not keep only a few bright, easily visible moons around it. Its powerful gravity can hold many smaller objects as well. Some orbit nearby, others travel very far away. Some move in the usual direction, while others follow tilted paths or orbit in the opposite direction from many of Jupiter's other moons. Before describing those paths with complicated terms, we can imagine them in a simpler way. If the 4 large moons are like boats, following fairly regular circles around Jupiter, many of the smaller moons are more like pieces of wood drifting farther away. They are still held by the planet, but their paths are not as neat. Some travel farther out, at steeper angles, more slowly, and are much harder to observe. Some small satellites lie closer to Jupiter, inside the region occupied by the 4 large moons. They are modest in size, dark in color, and usually very difficult to see from Earth. These inner moons may be connected to Jupiter's faint ring system. When small impacts knock dust away from their surfaces, that dust may help form the extremely thin rings surrounding the planet. Jupiter has rings as well, but they are not as bright or dramatic as the rings of Saturn. If Saturn's rings resemble a wide and easily visible piece of jewelry, Jupiter's rings are far fainter. They are more like a delicate layer of dust surrounding the planet. The small nearby moons may be one of the sources that continually supply dust to those rings. This makes the smaller moons more interesting than they might first appear. They are not merely tiny objects orbiting Jupiter. Some may help shape the dusty environment close to the planet. They are struck by small particles, lose a little material, and then that dust continues to drift within Jupiter's region of influence. Everything happens very slowly and faintly, almost beyond what the eye could ever notice. Yet, it still contributes to the appearance of the entire system. Farther away are small satellites with very wide orbits. They do not remain close to the planet like the major moons. Many of these distant satellites may once have been objects drifting through space before Jupiter captured them long ago. This does not need to be understood in a complicated way. We can imagine Jupiter as a planet with an extremely powerful gravitational pull. When small objects passed through its region of influence in the distant past, some were unable to escape. Instead, they remained behind and became moons. These distant small satellites usually do not have clearly rounded shapes. They are too small for their own gravity to pull them into spheres. Because of this, they may resemble uneven blocks of rock with dark, cold surfaces that change very little. Some are only a few kilometers across. Beside Ganymede or Callisto, they seem almost insignificant in size. But they still have their own value in Jupiter's story, because they show that this planet is accompanied not only by large worlds, but also by an entire crowd of smaller objects. Many of the small moons were discovered only recently because they are so faint. Astronomers have to use powerful telescopes, take many images over many nights, and compare them to see whether any point of light moves along with Jupiter. A distant star usually remains almost fixed against the background sky, but a small moon orbiting Jupiter shifts slightly from one image to the next. Through those tiny movements, astronomers eventually realize that the object is not a distant star, but a small satellite circling the giant planet. This work requires patience. A single observation is not enough to reveal the answer. A newly discovered object must be followed for long enough to determine its orbit. If it cannot be tracked, it may become lost. That may sound strange, but it is easy to understand. When an object is extremely small and faint, and its exact path is unknown, astronomers may not be able to find it again during the next observation among the countless other points of light. Because of this, the number of Jupiter's moons is not a figure that will remain fixed forever. As telescopes improve and surveys look deeper into the sky, human beings may discover even smaller satellites. Some will be officially confirmed once their orbits have been measured clearly enough. Others may require many more years of observation. This makes the Jupiter system feel like a region that is still being counted and mapped, rather than a list that has already been permanently closed. The smaller satellites also help tell the story of a more chaotic period in the solar system's past. Today, when we see planets moving along stable orbits, everything appears orderly. But early in the solar system's history, countless pieces of rock, ice, and smaller objects were moving in many directions. Giant planets like Jupiter had powerful gravity and could alter the paths of those objects. Some were thrown far away, some collided, others were captured and became moons. Seen in this way, the smaller moons resemble fragments left behind from a distant age. They are not large or bright, and they do not carry stories as dramatic as Europa or Io, but they may preserve clues about the ways small objects once moved around giant planets. They remind us that the solar system did not begin in a peaceful and stable condition. It was once a place filled with collisions, gravitational pulls, changes, and rearrangements. Some groups of small satellites orbit in the same general direction as the main Jupiter system. Other groups travel in the opposite direction. Without going deeply into terminology, we only need to understand that not all of Jupiter's small moons follow the same kind of path. Some have fairly orderly orbits. Others travel along paths that are more tilted, distant, and elongated. These differences lead scientists to think that many of the smaller moons may not have formed close to Jupiter. Instead, the planet may have captured them from somewhere else. This makes the Jupiter system feel like a place containing many layers of memory. The 4 large moons are clear worlds that are easy to observe and remember. The smaller moons are more like scattered pieces of a puzzle. They lie at different distances, follow different orbits, have different levels of brightness, and carry different histories. Not every piece stands out, but together, they make the picture around Jupiter more complete. Interestingly, these smaller satellites rarely appear in our imagination when we think about Jupiter. We easily remember the Great Red Spot, the bands of clouds, or the 4 Galilean moons, but by ignoring the smaller moons, we would be overlooking a significant part of the system. Their great number reveals just how far Jupiter's influence extends. The planet holds not only its major moons, but also many smaller objects traveling along a wide variety of near and distant orbits. We can imagine the region around Jupiter as a broad area with several levels. Close to the planet are faint rings of dust and several small inner moons. Farther out are the 4 large moons we have already visited. Beyond them are many more small satellites, darker and quieter, following wider paths. They all belong to the same system, but each group has a different role. The presence of these small moons also brings a sense of humility to the story of Jupiter. Although human beings have observed this planet for hundreds of years, some very small objects were discovered only recently. This means that even within the solar system, a region that seems more familiar than the distant reaches of the universe, there are still details waiting to be noticed. The smaller satellites do not create the overwhelming feeling of Ganymede. They do not raise the deep questions of Europa. They are not as violent as Io, or as clearly ancient as Callisto, but they have a beauty of their own, the beauty of things that are small and difficult to see. They show that around a giant planet, the most noticeable worlds are not the only ones that matter. Very faint and very small objects can still help make the system more real and more complete. Looking back, we can see that our journey around Jupiter has opened one layer at a time. First came the giant planet itself, with its clouds, winds, and storms. Then came the 4 great moons, each carrying a clear story of its own. And now, there are the smaller satellites, more numerous and harder to see, but making the Jupiter system far richer. The farther our attention moves from the center, the more we realize that Jupiter's region of influence does not end quickly. It stretches outward, holding far more objects than we might have imagined. From here, Jupiter is no longer the image of a single planet accompanied by a few famous moons. It becomes a vast system with a center, large worlds, smaller objects, faint rings of dust, and orbits both near and far. That complexity does not need to feel overwhelming. We only need to understand one simple idea. Around Jupiter, far more is moving than the unaided eye could ever see. And as the smaller moons slowly fade into the background of our imagination, our attention can return to the region closer to the planet, where a very thin layer of dust forms Jupiter's faint ring system. It is not as brilliant as Saturn's rings, and not as famous as the four great moons, but those delicate rings are still a quiet and subtle part of the Jupiter system, like a faint trace wrapped around the giant planet. After passing the four large moons and the wider group of smaller satellites, our attention begins to move toward the more distant regions of the Jupiter system. Here, the objects become less familiar. Their shapes are irregular, their orbits are unusual, and they are rarely mentioned in books or articles. These are Jupiter's distant, smaller moons, some of which were overlooked for a long time because they were too faint or too difficult to observe. These moons are nothing like the four Galilean satellites. They are small, often only a few kilometers across, with irregular shapes and dark, rough surfaces. Some resemble fragments of rock or ice held within Jupiter's gravitational pull, perhaps wandering through space before the giant planet captured them. They may lie relatively close to Jupiter, or travel along distant, tilted orbits. Some even move in the opposite direction from most of the other moons. This wide variety of distances and orbital paths makes the Jupiter system far richer than it first appears. From a human point of view, these small objects may seem simple, but when we observe them more carefully, we begin to see that they carry clues about the history of the giant planet. Some may be fragments left behind by ancient collisions. Others may once have wandered freely through space before being captured by Jupiter. When we consider this entire collection of unusual moons, they begin to resemble scattered pieces left behind by a chaotic process of formation, when gravity and collisions repeatedly change the paths and destinies of small objects around the planet. Discovering these satellites is not simple. They are far too small and dark to be seen with the naked eye. Astronomers must take many images over many nights, following individual points of light and comparing their positions to determine their orbits. A faint point that moves steadily under Jupiter's gravitational influence may be a moon. If its movement does not fit the expected path, it may be ruled out. This process demands time, patience, and many repeated observations, because these tiny objects can easily be confused with distant stars in the background sky. These small and unusual satellites may also be connected to Jupiter's thin ring system. When impacts knock particles of dust from their surfaces, those particles can help form faint layers of material orbiting the planet. We might imagine them as tiny petals drifting away from these small moons, adding subtle detail and additional layers to the Jupiter system. One interesting feature is that the distant moons often follow tilted or retrograde orbits, while the large moons travel along stable paths close to Jupiter's equatorial plane. These unusual satellites move along more inclined routes, sometimes crossing at steep angles or traveling in the opposite direction. This suggests that they may not have formed at the same time or in the same region as the larger moons. Instead, they may have originated elsewhere and later been captured by the giant planet. These moons are usually distant, faint, and rarely discussed. But when we look at the system as a whole, they make Jupiter's surroundings more complete and more complex. We no longer see only a few remarkable moons circling the planet. We see an entire network of movement around it, made up of large worlds, small fragments, and unfamiliar objects. Each one follows its own orbit, keeps its own rhythm, and carries its own story of how it came to be near Jupiter. A closer look also reveals great variety in their shapes and orbital speeds. Some objects remain close to Jupiter and move quickly. Others lie much farther away and travel more slowly. Some move backward, while others follow steeply tilted paths. These differences show that a giant planet like Jupiter is not merely a central body surrounded by a few large moons. It holds many smaller fragments as well, each carrying a story about gravity, collision, and a long journey through space. These small and unusual satellites also remind us that, in the universe, importance does not belong only to large objects. A tiny, faint body following a distant orbit may still contain clues about planetary formation and the way planetary systems evolve. These moons are like background details in a much larger painting. They may not stand out immediately, but they make the full image of the Jupiter system more vivid and more complete. When we observe them for long enough, the orbits of these unusual moons seem to form different layers around the planet. Some belong to regions closer to Jupiter. Others travel much farther out. Some groups move in the same direction, while others move in reverse. The system may appear complicated, but it is not simply chaotic. These objects continue along stable paths, still held within Jupiter's gravitational influence. This layered arrangement creates the feeling of a vast, many-level world surrounding the planet. Taken together, these small and unusual objects show us that Jupiter is not merely a giant planet with several prominent moons. It is the center of many layers of orbiting bodies. 4 large satellites, dozens of smaller moons, and even fainter objects traveling farther away. When we observe more carefully, each small piece contributes to making the Jupiter system more varied, more abundant, and more fascinating than the first impression we receive from Earth. This opens a quiet but intriguing thought. Even though human beings have observed the Jupiter system for hundreds of years, countless small details may still be waiting to be recognized. These strange little moons continue moving silently through space, nearly invisible but filled with meaning, forming an essential part of the larger story of the giant planet and everything that travels around it. After passing the large moons, the smaller satellites, and the faint dust surrounding Jupiter, we can step back for a moment and look at the entire system in a calmer way. At first, Jupiter appeared as an enormous planet. We noticed its size, its broad cloud bands, and the famous red storm within its atmosphere. But the longer we remain, the more we realize that Jupiter is remarkable not only because of the planet itself. Around it lies a vast region of motion, where objects large and small continue along their own orbits. Some are worlds large enough to have clearly visible surfaces. Others are so small that they appear only as faint points through a telescope. There is dust, ice, rock, nearby orbits, and other paths that extend much farther away. At a quick glance, all of this may look like only a few points of light moving around a large sphere, but as each layer is revealed, the Jupiter system becomes richer. Close to the planet is a thin layer of dust, forming an extremely faint ring. Farther out are the large moons that once changed the way human beings understood the universe. Beyond them are many smaller, darker moons that are difficult to see, some of which may be fragments captured by Jupiter long ago. All of them belong to the same vast region shaped by the planet's influence. What is remarkable is that none of these objects move in complete disorder. Each follows its own path. Some orbit faster, while others move more slowly. Some lie close to the planet, while others travel much farther away. Some follow fairly regular orbits, while others move along wider, more tilted paths. From a distance, the Jupiter system may feel like a giant clock, though not a clock made of rigid gears. It is a system moved by gravity, time, and orbital cycles that have continued through countless years. Jupiter holds the central position. Its gravitational pull is extremely powerful, strong enough to keep many moons and smaller objects around it. But that gravity does not make every place the same. Instead, each world is affected differently depending on its distance, size, and individual history. Some are stretched and compressed so strongly that their interiors become heated. Some are covered in ice and may hold water far beneath the surface. Some have surfaces that are renewed over time. Others change very little and therefore preserve a great number of ancient impact marks. Seen in this way, Jupiter is not simply a large planet with many satellites. It resembles the center of a region where different kinds of worlds exist together. The planet at the center does not need to shine like a star, yet it still creates order throughout the space around it. The smaller objects do not simply drift away. They follow their own paths, remain influenced by the giant planet, and still preserve traces of their individual histories. There is something very easy to overlook. The moons do more than simply orbit Jupiter. They also help us understand the planet in a different way. A giant planet would seem much simpler if we looked only at its clouds and storms. But when we observe the objects around it, we begin to see the strength of its gravity, the diversity of different surfaces, and the contrast between near and far, hot and cold, highly active, and almost unchanged. The satellites are like signs placed throughout the surrounding region, helping us read Jupiter's influence across many different distances. The large moons provide the clearest images. One is filled with powerful volcanic activity that continually changes its surface. Another is covered in ice, with the possibility of liquid water deep below. One is so large that it exceeds the size of a small planet, with bright and dark regions across its surface and a magnetic field of its own. Another lies farther out, older and more heavily marked, preserving countless impact craters left by objects that once fell upon it. Simply remembering these features is enough to show that there is nothing monotonous about the region around Jupiter. But the smaller satellites make the story more complete. They do not have dramatic appearances. Many are not round, not bright, and not easy to picture. Yet they reveal just how broad and crowded Jupiter's surroundings truly are. Some may provide dust for the planet's faint rings. Some follow distant orbits and may once have been wandering objects before Jupiter captured them. Others are so small that discovering and tracking them requires extraordinary patience. Because of them, the Jupiter system no longer resembles a neat model in a textbook. It feels more like a real place, filled with details both obvious and difficult to see. When thinking about this system, we can picture it in layers. At the center is the giant planet, with its deep atmosphere, thick clouds, and enormous storms. Closer around it is a faint layer of dust, very different from Saturn's famous bright rings. Beyond that are the large moons, the clearest and most recognizable worlds in the system. Farther away are smaller, dimmer satellites following more complicated paths. No layer stands entirely on its own. Everything lies within Jupiter's gravitational influence, together forming a system far larger than a single planet. This also helps us understand why Galileo's discovery, more than 400 years ago, was so important. When he saw several small points of light near Jupiter, the change was not simply that human beings had discovered a few new moons. More importantly, the sky could no longer be understood in the old way. Earth was not the only center of celestial motion. Another planet also had objects orbiting around it. Just a few tiny points of light opened a much broader way of understanding humanity's place in the universe. Today, as telescopes and spacecraft provide more data, those points of light are no longer faint and unnamed. They have surfaces, colors, structures, histories, and questions of their own. What Galileo once saw as a few lights beside Jupiter has become an entire layered system. This transformation shows that science sometimes begins with something very small, a point of light shifting from one night to the next, a patient record of observations, and a question without an immediate answer. The Jupiter system also reminds us that the universe does not inspire wonder only through enormous things. Jupiter's size is, of course, difficult to ignore. So is its great storm. But the longer we observe, the more the smaller details begin to carry value of their own. A very faint trail of dust, a small moon only a few kilometers wide, a tilted orbit, an ancient impact crater, a fracture across an icy surface. These details are not loud or dramatic, but they make the story complete. Perhaps this is the most beautiful part of looking at the Jupiter system as a whole. The central planet is immense, but the smaller objects around it are not meaningless. Each has its place. The large moons show us clearly defined worlds. The smaller satellites preserve signs of capture, collision, and dust. The faint rings reveal particles of matter so tiny that they almost disappear, yet still numerous enough to create a delicate layer around the planet. When everything is brought together, Jupiter becomes a place where many forms of motion overlap, from the very large to the extremely small. And that makes our journey around Jupiter very different from how it began. At first, we may have imagined only a giant gas planet. Then we discovered its clouds, its storms, its great moons, its smaller satellites, and finally its dusty rings. Each step made the image slightly wider, not by adding too much information to remember, but by helping us recognize one simple truth. Around a planet, an entire system of worlds and objects can quietly travel together. From far enough away, the Jupiter system would no longer appear as a collection of separate details. We would see one great center, paths of motion surrounding it, points of light both near and far, and a thin layer of dust that is almost invisible. Everything would still be following its orbit. No sound would travel through the emptiness. No collision would echo to our ears. But that silence would not mean that nothing was happening. On the contrary, within that silence, motion would continue without pause. Jupiter would still be rotating. Its cloud bands would continue changing shape. The large moons would keep passing through familiar positions along their orbits. The smaller satellites would silently follow their more distant paths. Dust would continue drifting within the faint rings. All of this would happen without anyone needing to be there to observe it. These objects were moving before human beings had telescopes, and they will continue moving long after we turn our eyes away. By this point, Jupiter no longer feels like an isolated object standing alone in space. It feels like a region with an order of its own, where planet, moons, and dust together form a vast system. We do not need to call it a miniature solar system in a completely literal sense, but the feeling is easy to understand. There is a powerful center, many objects moving around it, different orbits, and many smaller stories contained within the same region of influence. The longer we look, the more we realize that this richness does not make the story more confusing. It only makes Jupiter feel more real. A real planet is not only a number describing diameter or mass. It is clouds, storms, gravity, moons, dust, orbits, impacts, and time. It is what we can see directly, and also what can only be recognized through patient observation. And so, our attention does not leave Jupiter with the feeling that everything has been understood. Instead, it moves on with the sense that many layers around the planet still deserve to be seen more slowly. The large moons have given us powerful images. The smaller satellites have opened a dimmer, less familiar region. And the dust around the planet will carry the story toward one final delicate detail. Jupiter's rings not brilliant, not easy to see, but quietly surrounding the giant planet like a faint trace left behind by small collisions in space. Some things in space do not impress us through brilliance. They are not as large as a planet. They do not stand out like a giant storm. They have no clear surface that we can describe through volcanoes, ice, impact craters, or hidden oceans. They are almost nothing more than a very thin, very delicate layer resting quietly around a world far larger than themselves. Without looking in the right way, we could pass by without ever realizing they were there. Jupiter's rings are one of those details. When we think about planetary rings, most of us immediately picture Saturn. The familiar image of Saturn surrounded by broad, bright rings has become almost inseparable from the planet itself. Its rings are clear, beautiful, and instantly recognizable in almost any photograph. Jupiter also has rings, but they do not appear in the same way. The rings around Jupiter are far fainter. They do not resemble a large, shining piece of jewelry wrapped around the planet. Instead, they are more like an extremely thin and pale layer of dust, almost disappearing into the darkness without the right observing equipment. This is why most people remember Jupiter through its cloud bands, the Great Red Spot, or its more prominent moons. Its rings remain closer to the edge of the story, small and subtle enough to be easily overlooked. These rings are made mostly of dust. They are not composed of large, bright pieces of ice that are easy to see. They are not enormous blocks of rock arranged into circles. They are simply countless tiny particles drifting around the planet. Each individual grain of dust seems insignificant, but when a great number of them occupy the region around Jupiter, they form a thin layer surrounding the planet, one that spacecraft can detect. We can imagine it as a dark room with a narrow beam of light passing through it. Under ordinary conditions, we do not notice the dust floating in the air, but when the light enters at the right angle, the tiny particles begin to appear, drifting slowly through the beam. They do not shine by themselves. They become visible only when light touches them in the right way. Jupiter's rings create a similar feeling. Not brilliant, not easy to notice, but still present. The source of this dust is connected to the small moons close to the planet. These objects are not as prominent as the larger moons. They may be dark, rough, and irregular in shape, but when small particles moving through space strike their surfaces, some dust is knocked away. Those grains do not fall downward as they would on Earth. They continue drifting within Jupiter's gravitational influence and gradually contribute to the faint ring system around the planet. In other words, the rings were not created by one great event. They are maintained by countless small collisions. Each impact releases only a very small amount of dust, but over long periods of time, those particles gather into a thin layer of material surrounding Jupiter. This is what makes the rings so interesting. They do not tell their story through one dramatic scene. They tell it through small, repeated, quiet processes. One grain of dust is released from a tiny moon. Another continues along its orbit. Many particles remain together around the planet. Eventually, something that appears almost insignificant becomes a real structure. Jupiter's rings were discovered relatively late compared with the planet's more famous features. Human beings have known Jupiter since ancient times. Galileo observed its large moons at the beginning of the 17th century, but the rings were so faint that they could not easily be seen from Earth. It was not until the Voyager spacecraft passed through the region in 1979 that human beings clearly confirmed that Jupiter also had rings. That detail is worth remembering. It shows us that even a familiar planet can still hide features that are difficult to see, not because they are too far away, but because they are too thin, too faint, and too subtle. Some things in the universe do not hide themselves in complete darkness. They simply do not stand out enough for human eyes to notice them immediately. Jupiter's ring system has several different parts, but there is no need to go deeply into their names. What matters more is the overall impression. A faint layer of dust, close to the planet, connected to the small inner moons and held in place by Jupiter's gravity. It is not separate from the rest of the system. It is the result of small objects, small collisions, and long stretches of time. If the large moons are clearly defined worlds with shapes and surfaces that we can describe, the rings are like an almost invisible presence between those worlds. They have no volcanoes to observe, no fractured ice, no enormous impact craters. They are only dust. But that dust shows us that the Jupiter system is not made only of large objects. Even its smallest particles can contribute to the structure of the whole. One grain of dust cannot change a planet. It is far too small. But millions or billions of grains traveling around Jupiter can create a ring. The idea is easy to understand, yet quietly beautiful. In space, some structures are not created by one large object, but by countless small things existing together. These faint rings also help reveal the connection between different parts of the Jupiter system. Small moons may provide the dust. The dust forms the rings. The rings remain within the gravitational region of the planet. Jupiter holds everything within a wider order. No part stands entirely alone. One small detail can be connected to another, and together they create a more complete image of the giant planet. If we imagine a spacecraft passing close to Jupiter, the view might feel very strange. First, Jupiter would fill almost the entire field of vision, with its enormous cloud bands and familiar colors. The moons might appear farther away as points of light or small spheres, but close to the planet, if sunlight entered at the right angle, a very faint layer of dust might become visible. It would not make the scene brilliant, but it would reveal that a thin veil of material was drifting around Jupiter. That feeling would be very different from looking at Saturn. Saturn impresses through the clarity of its rings. Jupiter is more discreet. Its rings are like a small reminder that not everything in space needs to appear enormous before our eyes. Some details can be discovered only by moving closer, looking more carefully, and being more patient. That quietness fits naturally with the journey we have followed. At first, we looked at the largest and easiest things to see: the giant planet, its enormous storm, and its prominent moons. Then we moved towards smaller things: faint satellites, distant orbits, dark objects, and now dust. The deeper we move into these details, the less Jupiter resembles a simple image. It becomes a system with many layers, from large worlds to particles of matter almost impossible to see with the naked eye. The rings also show that collisions in space do not always create dramatic scenes. Sometimes, an impact releases only a little dust. There is no great flash of light, no explosion that can travel as sound through space, and no obvious sign that we would immediately notice. But over time, those small collisions still leave a result. A faint ring of dust is evidence that many minor events have taken place. This makes Jupiter feel more like a real natural system. In nature, large events are not the only ones that matter. Small things repeated over long periods can also create change. One drop of water does not immediately wear away stone, but many drops over a long time can leave a mark. One grain of dust cannot make a ring, but countless particles can form one around a planet. For Jupiter, that faint ring system is one of the lightest parts of the story. It does not replace the moons. It does not compete with the great red spot. It does not make us forget the enormous cloud bands. It simply adds another layer, a layer of dust, small collisions, and tiny objects close to the planet. Jupiter does not possess only the power of size and gravity. It also has the ability to hold on to things that are extremely small. From the great moons to the minor satellites, from dark objects to faint grains of dust, everything remains within its region of influence. The rings are a very delicate sign of that power. And perhaps what makes Jupiter's rings memorable is their modesty. They do not try to become the most prominent image. They do not shine brightly or take over our attention. They simply exist quietly near the planet, almost dissolving into the darkness, waiting for a spacecraft or the right angle of light to reveal them. Beyond that faint layer of dust, our attention can return to Jupiter itself. The central planet is no longer only a place of clouds and storms. It now carries with it its large moons, smaller satellites, and the thin ring system surrounding it. Every detail we have passed tells us the same thing. Jupiter's gravitational influence is vast, wide enough to hold great worlds, small objects, and even tiny grains of dust within one shared region of motion. Beyond everything we can see, Jupiter also has a region of influence that cannot be observed directly with the naked eye. It surrounds the planet like a vast invisible domain, where small particles are pulled, guided, and swept into an environment far more powerful than its quiet appearance might suggest. A tiny grain of dust is thrown from the surface of a moon close to Jupiter. It may come from a small collision. A minute piece of rock moving through space strikes the moon's surface and knocks several particles loose. Some of them contribute to the faint ring system mentioned earlier. But dust is not the only thing surrounding Jupiter. Close to the planet are particles even smaller and more difficult to see, yet moving with far greater energy. These are charged particles. In simple terms, charged particles are extremely small pieces of matter that can be affected by electric and magnetic forces. On Earth, we do not often think about them in everyday life, but they are present throughout space. When they enter the region around a planet with a powerful magnetic field, they do not simply continue flying freely in a straight line. They are deflected, guided along curved paths, and sometimes accelerated. This is especially important around Jupiter. The planet has an extraordinarily powerful magnetic field. A magnetic field is the region around a planet that can influence charged particles. We cannot see a magnetic field with our eyes, just as we cannot see the wind. But we know the wind is there when leaves move, smoke is pushed aside, or ripples appear across water. In the same way, we know a magnetic field is present when charged particles change direction and create effects that can be observed. Earth also has a magnetic field. One of its most beautiful visible signs is the aurora. When energetic particles from the sun enter regions near Earth's poles and interact with the atmosphere, the sky may glow in bands of green, purple, or red. Those lights are not the magnetic field itself, but they are signs that the field is guiding energetic particles. Jupiter also has auroras, but there, everything is much more powerful. Jupiter's magnetic field is larger and stronger than Earth's. Because of this, the region around the planet contains more energetic particles, stronger radiation, and a much harsher environment. To the naked eye, the space around Jupiter might appear dark and still. In reality, countless tiny particles are moving through it at very high speeds. What makes this region different is that it does not receive particles only from the Sunday. Some of the material comes from within the Jupiter system itself, especially from the volcanic moon Io. Io's volcanoes release sulfur and other substances. Some of that material escapes into the space surrounding the moon. It is then carried along by Jupiter's magnetic field, becomes electrically charged, and forms a region of material around the planet. This means that a volcanic eruption on Io does not affect only Io. Material released from the moon can enter the space around Jupiter and become part of the wider environment. This is how a relatively small moon can help make the regions surrounding its parent planet more powerful and more complex. We can imagine the area around Jupiter as a place filled with countless small movements that the human eye cannot see. Dust from the inner moons forms faint rings. Material from Io produces many charged particles. Jupiter's magnetic field carries those particles around the planet. As a result, the space close to Jupiter is not a calm emptiness, but an environment filled with intense radiation. The radiation here is not like the gentle, visible light we normally see. It is energy carried by rapidly moving particles. These particles can damage electronic equipment if a spacecraft remains in the region for too long. Because of this, probes traveling close to Jupiter must be carefully protected and must follow carefully planned flight paths. They are not simply traveling to a distant planet, they are entering a dangerous region of space. But the source of this powerful magnetic field lies deep inside Jupiter. Jupiter is made mostly of hydrogen and helium. Under ordinary conditions, hydrogen is a very light gas. But deep inside Jupiter, the pressure is far greater than anything familiar on Earth. The deeper we go, the more heavily the material above presses down on the layers below. Hydrogen is compressed so strongly that its properties begin to change. Under these extreme conditions, hydrogen may become a form of matter that conducts electricity. This form is called metallic hydrogen. The name may sound strange, but the idea is simple. The same substance can change when the conditions around it change. Water becomes ice when it is cold, and vapor when it is heated. Hydrogen inside Jupiter also changes into a different form when it is placed under immense pressure. As this electrically conductive material moves inside a rapidly rotating planet, it helps generate a magnetic field. This is why Jupiter's deep interior is connected to the space far beyond its clouds. What happens beneath the visible atmosphere can create effects that extend far outward around the planet. So when we look at Jupiter, we should not think only about the parts visible in photographs, the cloud bands, the great red spot, or the colors of the atmosphere. These features are striking, but they are not the entire story. Beneath the clouds are immense pressure, compressed hydrogen, internal motion, and the source of the planet's magnetic field. Outside, the clouds are charged particles, radiation, dust, and material released from the moons. This helps us understand why Jupiter has such a powerful influence on its satellites. The moons are not only held in orbit by gravity, they also travel through a region filled with energetic particles. On an icy moon, those particles can affect the surface over long periods of time. In Io's case, material released by the moon is drawn into Jupiter's surrounding environment. None of the moons are completely separate from the planet they orbit. To summarize it with one simple image, Jupiter is like a planet with an enormous body and a very wide region of influence around it. The body is what we can see: clouds, storms, and colors. The surrounding region is what we cannot see directly: the magnetic field, charged particles, and radiation. Together, they form Jupiter's true environment. This region also explains why exploring Jupiter is so difficult. A spacecraft traveling close to the planet must endure cold temperatures, an immense distance from Earth, and especially powerful radiation. Electronic instruments are highly sensitive. Without sufficient shielding, they can be damaged. Every time a spacecraft flies near Jupiter, scientists must find a balance between moving close enough to make valuable observations and avoiding spending too much time in the most dangerous regions. Yet this intense environment is also one of the reasons Jupiter is so valuable to study. Its magnetic field reveals how the planet's interior is functioning. Its auroras show how energetic particles enter the atmosphere. Material from Io reveals how a moon and its parent planet can influence one another. The radiation shows that the region around Jupiter is not empty space, but an environment with structure and constant motion. Once we understand this, the faint rings from the previous chapter also fit more naturally into the larger picture. Dust is small matter that becomes visible under the right lighting conditions. A magnetic field is an invisible region of influence that can be detected through the behavior of charged particles. Both tell us the same thing: much more exists and moves around Jupiter than the unaided eye can see. Jupiter is therefore not only large in physical size, its region of influence is vast as well. It holds moons in orbit through gravity. It creates rings from dust released by smaller satellites. It pulls and guides charged particles through its magnetic field. It produces auroras near its poles. It turns the space around it into one of the most powerful environments in the solar system. From far away, everything may look peaceful. A giant planet rests in space. A few small points of light move around it. A ring system remains too faint to see easily. But once we understand Jupiter's magnetic field, that stillness no longer feels like emptiness. It is the stillness of a place too distant for us to hear, yet filled with tiny movements, energy, and influence. Beyond the thin dust of the rings, the magnetic field reveals another side of Jupiter, invisible, yet immensely powerful. It has no beautiful shape like the cloud bands. It is not as easy to describe as a moon with a visible surface, but it helps explain why the region around Jupiter is so unusual, why spacecraft must travel carefully, and why Jupiter is far more than a giant sphere of gas. Once we know that Jupiter is surrounded by powerful radiation, charged particles, and an enormous magnetic field, we can better understand why every signal sent back from that region is so valuable. Those small spacecraft are not merely traveling to a distant place. They are entering the domain of a giant planet, where invisible forces are just as important as everything revealed by light. After traveling through Jupiter's clouds, storms, moons, faint rings, and invisible region of influence, a very natural question begins to arise. How do human beings know all of this? Jupiter lies at a distance that makes it impossible for us to approach it in any familiar way. We cannot step down onto a solid surface. We cannot build an observation station among its deep cloud layers. And we cannot see its moons with our own eyes as clearly as we might look at a landscape outside our home. To understand this planet, human beings must rely on tools that can see in our place. Telescopes, observatories, and spacecraft sent across space over many years. Through these tools, Jupiter has gradually revealed itself one layer at a time. At first, it was only a bright point and a few faint cloud bands. Later came the enormous storm, the moons, the thin rings, the powerful magnetic environment, and details that the human eye could never have seen on its own from Earth. Those spacecraft are not large when placed beside Jupiter. Compared with this giant planet, they are only tiny pieces of metal drifting through the darkness. Yet those small pieces of metal have carried human eyes, ears, and memory closer to a world we cannot touch directly. Before spacecraft arrived, Jupiter was observed mainly from a distance. Human beings saw it first as a bright point, and then through telescopes, they began to see its cloud bands, the Great Red Spot, and its large moons. But observing from far away always has limits. Some details are too small, too faint, too fast, or too deeply hidden for earlier telescopes to fully understand. To learn more, human beings had to send instruments closer. The first spacecraft flybys of Jupiter were like brief touches upon an unknown region. The spacecraft did not remain there for long. They passed by, observed, measured, photographed, and then continued on their journeys. But even those short encounters changed a great deal. Through the first images and measurements, Jupiter began to appear as more than a distant sphere. It had a complex atmosphere, an intense radiation environment, moons that were clearly different from one another, and features human beings had never before seen from so close. We can imagine this kind of flyby as a traveler passing through an unfamiliar city aboard a train at night. The traveler does not step off or remain there for long, but through the window, there is still enough time to glimpse lights, streets, buildings, and a few signs that reveal how different the city is from anywhere previously known. For the spacecraft passing Jupiter, every photograph and measurement was like a small window opening for only a short time. Then came a more important step. Instead of merely flying past, human beings sent a spacecraft to remain in orbit around the planet. This was a major change. A flyby is like seeing a place for a moment. Orbiting is like having enough time to return again and again, observing from different angles, watching changes across days and months, and understanding more clearly how a system works. The Galileo spacecraft marked one of these milestones. It became the first spacecraft to orbit Jupiter for several years. By remaining there longer, Galileo allowed human beings to observe the planet, its large moons, and the surrounding environment in much greater detail. It also released a small probe into Jupiter's atmosphere, giving humanity its first direct data from inside the gas layers of the giant planet. That image is worth remembering. A larger spacecraft remaining in orbit, while a smaller probe descended into the atmosphere. The probe could not survive for long within Jupiter's harsh environment. The pressure, temperature, and winds inside the planet were too intense. But during the brief time before its signal disappeared, it still sent back valuable information. In some places in the universe, only a few minutes of data can lead to many years of study. After Galileo, Jupiter became clearer in human understanding. Its moons were no longer only points of light. Their icy surfaces, fractures, impact craters, signs of volcanic activity, and the possibility of water beneath them could be examined in more specific ways. The central planet was no longer only a striped sphere. It became a dynamic gaseous world with deep clouds, powerful winds, and an extremely intense magnetic and radiation environment. Yet many parts of Jupiter remained unclear. A giant gas planet cannot be understood through external images alone. Its beautiful cloud bands are only the uppermost layer. Beneath them lie deeper regions where pressure and temperature change in ways very different from anything familiar on Earth. Human beings wanted to know how the planet formed, what exists inside it, how much water it contains, how powerful its magnetic field is, and why its atmosphere behaves in such complex ways. That is why Juno was sent to Jupiter. Unlike spacecraft that only flew past, Juno entered orbit around the planet in 2016. It was designed to observe Jupiter more deeply, not only by photographing its exterior, but also by measuring its gravity, magnetic field, radiation, and signals coming from beneath the clouds. In simpler terms, if photographs show us Jupiter's face, Juno's measurements help human beings study what lies behind that face. One of the things that makes Juno special is its orbit. The spacecraft does not circle Jupiter along a close, even path as we might normally imagine. Instead, it follows a long, narrow orbit, sometimes passing very close to the planet before traveling far away again. This path reduces the amount of time Juno must spend inside Jupiter's most intense radiation zones, while still allowing it to observe the planet from close range during each pass. The environment around Jupiter is far from gentle. Radiation there is powerful enough to damage electronic equipment unless it is carefully protected. Because of this, spacecraft approaching the planet must be designed like travelers moving through a dangerous, invisible storm. They need protective shielding, carefully planned flight paths, and precise calculations that allow them to collect data while extending the life of their instruments. Images from Juno have revealed Jupiter from very different angles. The planet's polar regions are especially striking because they look nothing like the familiar cloud bands near the equator. There, many large atmospheric vortices form complex arrangements, making Jupiter appear both familiar and strange. In the past, when human beings observed the planet from far away, attention was usually drawn to its horizontal cloud bands. But when Juno passed over the poles, another face of Jupiter began to emerge. Juno has also helped human beings understand the planet's magnetic field more clearly. Earlier, we spoke about the invisible region of influence surrounding Jupiter. From a distance, this can be difficult to imagine, but spacecraft measurements show that Jupiter's magnetic environment is not only powerful, but also highly complex. It affects charged particles, the environments around the moons, and the way Jupiter interacts with the space surrounding it. Another important point is that missions to Jupiter do not study only the central planet. Over time, human attention has increasingly turned toward its moons, especially the icy worlds that may hide water beneath their surfaces. New missions therefore ask more than simply, what is Jupiter? They also ask, what remarkable environments exist around Jupiter? What can its moons teach us about water, ice, heat, and the possibility of conditions suitable for life? Europa Clipper is one example of this direction. Rather than traveling there to search directly for living organisms, the mission was designed to investigate whether Europa may have conditions that could support life. The spacecraft will orbit Jupiter and make repeated close passes by this icy moon, observing its frozen shell, measuring the surrounding environment, and helping human beings understand more clearly whether an ocean may exist below. The important point is that science does not rush toward conclusions. When a spacecraft is sent to a place like Europa, human beings are not claiming that life certainly exists there. The first things to investigate are the conditions. Is there liquid water? How thick is the ice? Is there a source of energy below? Could the necessary chemical materials exist there? Each small answer will help reveal another part of that world. The missions to Jupiter are therefore like a chain of connected questions. The first flybys showed that the planet was more complex than anyone had imagined. The first orbiter allowed human beings to remain long enough to study the atmosphere and the moons. Later missions looked more deeply into Jupiter's interior, polar regions, magnetic field, and radiation environment. The missions that follow are turning more of their attention toward the icy moons. Each generation of spacecraft does not replace the one before it. They continue what earlier missions began. Old data becomes the foundation for new questions. Earlier images lead to new plans. A discovery of fractures in an icy surface may inspire a mission to study a hidden ocean. A measurement of the magnetic field may help engineers design a safer flight path. A faint photograph taken decades ago may become the first step toward understanding a region that a more advanced spacecraft will later return to examine. There is a special kind of beauty in the way human beings explore Jupiter. We do not reach it through direct strength, but through small instruments calculations, patience, and time. A spacecraft may take years to arrive. Once it reaches the planet, it has only a limited amount of time to work. Every signal sent back to Earth must cross an immense distance. And when the data finally arrives, scientists may spend months or years studying it. This makes the exploration of Jupiter very different from simply looking at a beautiful picture on a screen. Behind every image is a long journey. Behind every measurement is an instrument that has endured cold, radiation, and distance. Behind every discovery are teams of people who calculated, waited, checked, and sometimes had to accept that answers would come very slowly. But that slowness feels appropriate for Jupiter. This is not a planet that can be understood in a hurry. It is too large, too deep, and made of too many layers. Spacecraft do not solve every mystery in a single visit. They only open one small door at a time. One door looks into the atmosphere, another looks toward the moons, another opens onto the magnetic field, another looks beneath the icy shell of a distant satellite. When we look back at the missions that have approached Jupiter, we see a long path shaped by curiosity. From the first flybys to the first spacecraft that remained in orbit, and from modern missions to the journeys now turning toward the icy moons, human beings continue returning to the same region of space. Not because everything has already been understood, but because the more we learn, the more questions Jupiter reveals. Perhaps this is one of the most natural qualities of science. Each answer does not completely close the story. It makes part of the story clearer while opening deeper questions. Learning that Europa may have an ocean beneath its ice makes human beings want to know how thick that ice is. Learning that Jupiter has a powerful magnetic field makes us want to understand how it is produced. Learning that the atmosphere has many layers makes us want to look farther beneath the visible cloud bands. The spacecraft that have traveled close to Jupiter are therefore more than machines. Within this story, they are like silent messengers. They have no emotions, but they carry human curiosity. They cannot speak, but they send back images, measurements, and delicate signals. From those signals, human beings rewrite the story of a distant planet. At this point in the journey, Jupiter appears not only through imagination, but through real traces left by exploration. Its cloud bands, storms, icy moons, faint rings, and powerful magnetic environment have all been observed, measured, or crossed by human-made instruments. That brings the giant planet a little closer, even though the physical distance through space remains immense. From here, the journey can move toward a different feeling. Instead of only looking at Jupiter from the outside, we can begin to wonder what lies deeper beneath the clouds. Although spacecraft have sent back an extraordinary amount of data, the planet's interior remains difficult to reach. Everything we see is only the outer layer. Beneath those familiar bands of color, Jupiter still holds a deeper story that has not yet been fully opened. After all the exploratory missions and the signals sent back from so far away, Jupiter still holds onto its most difficult mystery. What truly lies beneath those clouds? From the outside, the planet is already impressive enough. Bright and dark cloud bands wrap around its enormous body. The great red spot continues to swirl like an ancient mark within the atmosphere. Moons large and small keep circling around it, each carrying a story of its own. But all of these things still belong to the part we can see or study indirectly. Beneath those vast cloud layers lies another world deeper, heavier, and far more difficult to imagine. Jupiter does not have a familiar solid surface like Earth. This is important to remember as we begin thinking about the planet's interior. On Earth, if we travel downward beneath our feet, we pass through soil, rock, the crust, and then deeper layers of hot material. On Jupiter, there is no familiar transition from air to solid ground. If it were possible to descend through the upper clouds, we would not reach a clear surface where we could stand. Instead, the gas would gradually become denser, heavier, and hotter, until even the idea of gas no longer resembled the air we breathe each day. Jupiter is not a hollow sphere covered by clouds. nor is it a rocky planet hidden beneath a thick atmosphere. Most of the planet is made of matter existing in states very different from anything human beings normally experience. What we call clouds are only the outermost layer, like a thin layer of foam on the surface of an incredibly deep ocean, while an enormous mass remains hidden below and cannot be seen directly. As we move deeper, the pressure rises rapidly. Pressure is the force that surrounding matter places on everything within it. At the bottom of Earth's deepest oceans, pressure is already strong enough to crush anything that is not properly protected. But inside Jupiter, the pressure is far greater. Gas in the upper layers is compressed by the enormous weight of all the material above it. The deeper we go, the more tightly matter is squeezed. A region that first resembles gas gradually becomes as dense as a liquid, then continues changing in ways that are deeply unfamiliar. Jupiter is made mainly of hydrogen and helium. These are two very light elements and are both common throughout the universe. Hydrogen is the most abundant element, and helium is also widespread. But deep inside Jupiter, under enormous pressure, hydrogen no longer behaves like an ordinary gas. When compressed strongly enough, it can enter a more unusual state in which it conducts electricity like a metal. Before giving this state a name, we can understand it simply. The same substance can behave differently when placed under extreme conditions. Just as water can exist as vapor, liquid, or ice depending on temperature and pressure, hydrogen inside Jupiter can also become something very different when compressed deep within the planet. This state is commonly known as metallic hydrogen. The name may sound strange because we do not normally think of hydrogen as a metal. But deep inside Jupiter, where the pressure rises far beyond anything found in ordinary conditions, hydrogen can conduct electricity. This is a very important part of Jupiter's story because the layer of metallic hydrogen may be connected to the planet's powerful magnetic field. A magnetic field does not need to be understood in an overly complicated way. We can think of it as an invisible region of influence surrounding a planet, where electrically charged particles in space are affected. Earth also has a magnetic field, and it gives our planet a natural form of protection against some of the energetic particles coming from the Sun. Jupiter has a magnetic field as well, but it is far more powerful. One possible reason for that strength lies in the movement of electrically conductive material deep inside the planet. In other words, Jupiter's interior is not a quiet place. Although we cannot observe it directly, the material within is constantly moving, being compressed, heated, and carried along by the planet's rapid rotation. Those motions may generate the enormous magnetic field surrounding Jupiter, influencing the space around it as well as its moons. Another fascinating fact is that Jupiter releases more energy than it receives from the Sun. This does not mean that it is a star. Jupiter does not have enough mass to begin nuclear fusion as the Sun does, but the planet still retains heat left over from its formation long ago. When Jupiter formed from gas and dust in the young solar system, material fell inward, became compressed, and generated heat. Some of that heat continues to escape even today. We can imagine Jupiter as an enormous object that was compressed and heated in the distant past and is still releasing its remaining heat very slowly. It does not do this through flames or the brilliant light of a star, but through energy quietly traveling from the interior toward the outside. This internal heat may help keep Jupiter's atmosphere in constant motion, creating flowing currents, rotating regions, and storms that can last for a very long time. When we look at the Great Red Spot or Jupiter's cloud bands, we are seeing the outer layer of a planet with a powerful source of energy inside it. The clouds do not simply rest there like decoration. They are signs of motion, heat, rapid rotation, and streams of material rising, descending, and mixing throughout the atmosphere. What appears across the visible surface is connected to processes taking place much farther below, even though we cannot yet see through every layer. Another major question concerns Jupiter's core. Does it have a solid core? How large might that core be? Or has the material at the center gradually mixed into the layers above over time? This remains difficult to answer. Earlier models often describe Jupiter as having a dense central core made of materials heavier than hydrogen and helium. But modern data suggest that the core may not be as neat as a solid stone resting at the exact center. Its material may be mixed outward, with blurred boundaries, creating a central region that is not completely well defined. This makes Jupiter different from the simple image of a planet, divided into clear layers such as a crust, mantle, and core. With Earth, we can describe internal layers in a fairly familiar way. Inside Jupiter, the transitions may be more gradual. The planet may change from gas in its upper regions to denser material below, then to metallic hydrogen, and finally to a central region containing heavier elements. But the boundaries between these regions may not be as sharp as the lines shown in a diagram. When imagining Jupiter's interior, it is therefore better not to picture a ball cut into clearly separated bands of color. It may be more like a system that changes gradually from one region to another as matter enters different states under changing pressure and temperature. Each layer is not a flat, motionless surface, but a moving region where materials mix and respond to heat, gravity, and the planet's rotation. Jupiter's rapid rotation is also extremely important. A day on the planet lasts only about 10 hours. For an object this enormous, rotating so quickly creates powerful effects. The planet bulges slightly around its equator, atmospheric currents are stretched into bands, and the interior is also influenced by this rotation. Jupiter is not only large, it spins at an extraordinary rate for a world of its size. The combination of immense mass, deep pressure, internal heat, and rapid rotation makes Jupiter a physically dynamic planet. Dynamic here does not refer to life in a biological sense. It means that matter is always moving, energy is always being transferred, and processes are always continuing beneath the outer layers we can see. Even when Jupiter appears silent in space, its interior is far from motionless. Because the interior is so difficult to reach, every measurement is extremely valuable. Human beings cannot send an instrument deep inside Jupiter and wait for it to return. The environment is far too severe. A probe may enter the atmosphere and transmit information for a short time before pressure and heat cause it to stop working. For this reason, most of what we know about Jupiter's interior must come through indirect methods, measuring gravity, studying the magnetic field, observing the atmosphere, and then using scientific models to estimate what may lie below. This does not make the story unreliable. It simply shows that science can sometimes be like listening to a room behind a closed door. We may not yet be able to open the door completely, but we can hear sounds, feel vibrations, notice signs outside, and slowly learn more about what is happening within. In Jupiter's case, its cloud bands, magnetic field, gravity, and escaping heat are all clues of this kind. Perhaps the most fascinating thing about Jupiter's interior is the contrast between what is familiar and what is strange. Hydrogen and helium are common elements throughout the universe, but when they exist inside a giant planet under unimaginable pressure, they create a world very different from ordinary human experience. Clouds are familiar to us on Earth, but Jupiter's clouds belong to an atmosphere that is much deeper and more powerful. Storms are something we encounter through everyday weather, but storms on Jupiter can grow larger than our entire planet. Every familiar idea becomes broader and more difficult to grasp when placed within Jupiter. This is why Jupiter cannot be understood through a beautiful photograph alone. Images reveal its outward appearance, but the planet's deeper story also lies in what cannot be seen. The pressure beneath the clouds, deeply compressed hydrogen, heat remaining from the time of formation, an immense magnetic field, and a core that is still not fully understood. These are the silent layers beneath its colorful exterior. Looking back across our journey, we can see that many of the things surrounding Jupiter are connected to the power within it. Its magnetic field shapes the environment around the planet. Its gravity holds the moons in orbit. Its heat and internal motion prevent the atmosphere from becoming still. Every outward detail is connected by an invisible thread to the deeper regions, where Jupiter continues to hold its own energy and structure. Jupiter's interior is therefore like a part of the story that has not yet been completely told. We know it is there. We can see signs of it. We can measure its effects. But we cannot look directly into it as we might look at a rocky surface illuminated by sunlight. This allows Jupiter to retain a necessary sense of mystery, not a vague or imaginary mystery, but the mystery of a real place that is genuinely difficult to reach. After exploring the moons, rings, dust, and spacecraft missions, returning to Jupiter's interior gives the journey a deeper feeling. The planet is not only the center that holds many orbiting objects around it, it is also an enormous mass of material being compressed, rotating, releasing heat, and creating a region of influence of its own. What we see from the outside is only the beginning. As our attention settles again on the familiar cloud bands, we can understand that beneath them there is no surface waiting for someone to stand upon. Instead, there is a depth with almost none of the familiar features we know. A realm of pressure, heat, hydrogen, helium, and slow movement within the body of the planet. It is a place human beings cannot yet visit, but one we are gradually learning to understand through patience. Jupiter, therefore, feels both closer and farther away. It feels closer because observation and exploration have taught us so much more about it. Yet it also feels farther away because the more we understand, the more clearly we see that its deepest regions are not easily revealed. The giant planet continues to rotate silently, displaying its outer cloud bands, while an entire heavy and intensely hot world quietly exists below. After looking at everything surrounding Jupiter and everything that may lie within it, the story does not need to hurry toward another mystery. We can simply hold on to the feeling that a world very distant, very large, and very different from Earth is still moving out there, with cloud layers we can observe and deeper regions that human beings are continuing to understand little by little. As our journey around Jupiter reaches its final stretch, what remains is not only the image of a giant planet far from Earth. What remains is a quieter feeling that a small point of light in the sky can sometimes contain far more stories than the unaided eye could ever imagine. From the ground, Jupiter may look like nothing more than a bright star in the night. It does not twinkle strongly, does not visibly change shape, and does not reveal its cloud bands or moons to the naked eye. Someone may look at it for only a few seconds and then move on, never knowing that behind that point of light lies an enormous planet, a deep atmosphere, an ancient storm, a rich system of moons, a very faint ring, a powerful magnetic environment, and layers of matter inside that human beings are still trying to understand little by little. Jupiter is remarkable not only because it is large. Its size is the first thing that draws our attention, but it is not the last thing that stays with us. If we say only that Jupiter is the largest planet in the solar system, the story ends far too soon. Its vastness is more like a doorway opening into other layers. Clouds, storms, moons, dust, magnetic fields, pressure, heat, and deep regions that cannot yet be seen directly. The journey began with the easiest features to observe, the cloud bands. From far away, they resemble soft lines of color wrapped around the planet. But with greater understanding, we know that they are more than a beautiful appearance. Those bands are signs of an atmosphere in constant motion. Winds, heat, rapid rotation, and different atmospheric layers create bright and dark regions that stretch around the planet. A photograph of Jupiter may look still, but throughout that atmosphere, everything continues to move. Then there is the Great Red Spot, the striking red-orange region that allows many people to recognize Jupiter at a glance. From a distance, it looks like a colored mark among the clouds, but it is an enormous storm, wider than Earth, and it has lasted long enough to be observed by many generations of human beings. It reminds us that weather does not belong only to the rain and wind of our own planet. On a giant gaseous world, weather can grow larger than Earth and continue across spans of time that are difficult for a human lifetime to fully grasp. On Earth, a storm usually has somewhere to weaken. It may cross the ocean, move over land, lose strength, and eventually disappear. Jupiter has no solid land of that kind. There are no coastlines, mountains, or continents to interrupt the movement of the atmosphere. Everything takes place within a vast and deep layer of gas, where rotating systems may survive for a very long time. That fact alone changes the way Jupiter makes us think about a familiar word: storm. After the clouds and the great storm, our attention moved away from the central planet and toward its moons. There, the story opened in many different directions. One small world is filled with volcanoes, where forces inside continue pushing hot material toward the surface. Another is covered in ice and may conceal liquid water beneath its frozen shell. One moon is large enough to exceed Mercury in size, with bright and dark regions across its surface and an unusual internal structure. Another is older, preserving countless impact scars left behind by objects that struck it long ago. Those moons prevent Jupiter from feeling like a planet standing alone. It becomes the center of a region accompanied by many smaller worlds. There is fire, there is ice, there is rock and dust. There may be water hidden deep beneath a frozen shell. There are impact craters, preserving signs of an extremely distant past. Each moon is more than an object traveling beside Jupiter. It is a distinct part of a much larger story. What makes these moons memorable is not simply their individual names. What matters is how different they are from one another. If all of them were alike, the Jupiter system would be easier to understand, but far less rich. Reality is the opposite. One world is violent, another is cold and secretive. One is enormous, another is ancient. One makes us think of volcanoes, another makes us think of an ocean beneath ice. These differences make the region around Jupiter feel like a collection of many kinds of worlds, all held within the gravity of one giant planet. Beyond the large moons, the smaller satellites revealed another layer. They do not have memorable appearances. Many are extremely dark and small, irregular in shape, perhaps resembling fragments of cold rock or ice following distant orbits. Yet they make the Jupiter system feel more real. A natural system does not contain only its most dramatic features. It also includes small objects, ancient fragments, tilted paths, distant orbits, and traces left behind from a more chaotic period in the solar system's past. Those small satellites encourage us to slow down in the way we look at things. Something small is not always secondary. A faint object may offer a clue about an ancient collision. An unusual orbit may tell the story of something captured by gravity long ago. A nearly nameless fragment of cold rock may still be part of a much larger history. In space, the value of an object is not always measured by how brightly it shines or how large it appears. Then came Jupiter's faint rings. They are not as magnificent as Saturn's rings. They do not make the planet instantly recognizable in familiar photographs, but they are still there, made from extremely small grains of dust. That dust may come from gentle impacts against the small moons close to the planet. One individual particle is almost insignificant, but when countless grains remain together within Jupiter's gravitational influence, they can create a very thin ring. At this point, Jupiter begins to feel quieter. After the great storm and the remarkable moons, we encounter something that is almost only a trace, a layer of dust, a faint ring, a detail easily overlooked. Yet that dust shows us that very small things, when they persist long enough, can still leave a visible shape in space. Not every mark is created by one enormous event. Some are formed by many tiny events repeated over time. Beyond that dust lies the magnetic environment, a region that cannot be seen directly, but is extremely important. Here, Jupiter reveals its strength in another way. The planet is not large, only through the visible body we see. It is also large through the region of influence surrounding it. Charged particles, radiation, and material escaping from the volcanic moon all show that the space around Jupiter is not truly empty. From far away, everything appears silent, but that silence is not stillness. Tiny particles continue moving, material continues to be carried along, the magnetic field continues guiding charged particles. Invisible streams of energy continue making the region around Jupiter a powerful environment. Some things never appear in photographs, yet they quietly determine how a world and everything around it behave. Deeper still lies the interior of the planet. Jupiter has no solid ground where a person could stand. Beneath the clouds there is no familiar surface, but gas that becomes steadily denser, pressure that grows ever greater, and temperatures that rise with depth. Hydrogen, normally an extremely light substance, may be compressed into an electrically conductive form deep inside the planet. Those deeper layers help generate the powerful magnetic field outside. Once again, what cannot be seen helps explain what can. The beautiful cloud bands above are not completely separate from the deeper interior. The strong magnetic field surrounding the planet does not simply appear from empty space. Everything is connected: compressed matter, rapid rotation, heat remaining from the planet's formation, moving atmospheric layers, and small particles guided around Jupiter. If we look only at its appearance, Jupiter is a beautiful planet. If we look more slowly, we begin to see it as a system made of many layers. The clouds tell us about the atmosphere. The great storm tells us about large-scale motion. The moons reveal different kinds of worlds. The rings reveal dust and small collisions. The magnetic field reveals an invisible region of influence. The interior tells us that beneath the clouds lie pressure, heat, and matter existing in deeply unfamiliar states. But the most important thing is not to preserve all of this as a list. A journey like this does not need to end with the listener remembering every term. It only needs to leave behind a clearer feeling about the sky. What we see is often only the first layer. Behind a point of light may be a storm. Behind a storm may be an entire deep atmosphere. Around a planet may be moons, dust, magnetic fields, and internal layers that have not yet been fully revealed. When science is told slowly, it does not take away the wonder of the universe. It gives that wonder a clearer shape. Before we understand it, Jupiter is only a distant point of light. As we learn more, that light does not lose its beauty. It becomes a place of clouds, storms, moons, dust, and very real questions. The mystery does not disappear. It simply becomes deeper, clearer, and closer to the human imagination. That feels especially fitting for a story meant for sleep. There is no need to struggle to hold on to every detail. There is no need to turn Jupiter into a heavy lesson. We can simply allow each image to pass slowly. A giant planet, broad cloud bands, a red storm, a volcanic moon, a layer of ice that may conceal water, a faint ring of dust, an invisible field of force, and deep layers beneath the clouds. Each image can feel like a longer breath, carrying the mind away from the narrow concerns of the day. And from Jupiter, we can return with a different way of seeing the things closer to us. Some things appear simple on the outside, but contain many layers within. Some small details are easy to overlook, yet still help form the larger picture. Some questions do not have immediate answers, but that does not make them meaningless. A distant planet can remind us to look more slowly, not only at the universe, but also at the familiar things around us. Jupiter does not speak in words. It does not send humanity a complete answer. It simply exists, moving along its orbit with its clouds, storms, moons, dust, magnetic field, and deep interior. Yet that quiet existence is enough to leave us with a feeling. Some things do not need to be loud in order to be immense. Some motion continues without sound. Some places are very far away, yet can still reach the mind when we are patient enough to look. As Jupiter recedes in our imagination, it becomes a point of light once again. But now, that point of light is different. It is no longer an unnamed glow against the sky. It carries an entire system within it: clouds, storms, moons, dust, magnetic fields, and deep interior layers. All of these remain there whether or not we are watching. The planet continues to rotate. Its moons continue along their orbits. Grains of dust continue drifting near the planet. Beneath the clouds, matter remains compressed within an enormous depth. There is a gentle sense of calm in that thought. Not the calm of an empty place, but the calm of a world that continues to function far away. A world that does not need sound, display, or closeness to human beings in order to have meaning. It simply exists, vast and enduring within its own region of space. When we return to the night sky, we may carry a different way of looking. Every point of light may contain a story. Every planet may have a system of its own. Everything we do not yet understand may be a doorway rather than a wall. Jupiter is only one point in the wide sky, but when we look slowly, it opens into an entire journey. Perhaps when this story ends, the listener will not remember the names of every moon or every scientific detail. That is all right. What should remain is the feeling that distant worlds can still be understood one small step at a time. That science is not only a collection of measurements, but also the way human beings learn to look more deeply at things that first seem simple. That the night sky is not only darkness above us, but a place holding stories that stretch across immense spans of time. On some future night, when Jupiter appears as a quiet point of light, we may remember that behind that small glow is an enormous planet. There are broad bands of clouds. There is an ancient red storm. There are moons shaped by fire, ice, rock, and the marks of time. There is a faint layer of dust that is almost impossible to see. There is a powerful magnetic environment. There are deep regions that human beings still cannot observe directly. We do not need to name everything. We do not need to understand every detail in order to find it beautiful. It is enough to know that somewhere beyond us, a point of light that once seemed small to the human eye has become an entire world within the mind. Sometimes, a change as simple as that is enough to make the sky feel deeper, quieter, and more familiar in the night. As the sound of the story begins to slow, let Jupiter continue turning within the imagination. There is no need to follow it. There is no need to hold tightly to every image. Simply allow the planet to drift gradually farther away, like a great sphere of clouds returning to its place in space. The moons grow smaller. The cloud bands blend into a pale light. The deep interior remains beyond sight. But the feeling of Jupiter remains. Vast, quiet, enduring, and filled with layers whose stories have not yet been completely told. That may be the gentlest gift of a journey around Jupiter. Not a final answer, but a slower way of seeing. A way of remembering that in the universe, as in many parts of life, what we notice first is often only the outer layer. With enough patience, behind a point of light, there may be an entire world. Behind a simple question, there may be a long journey. And behind the silence of the sky, countless forms of motion are still taking place quietly, far away, but truly there.